All right, part 2. Question 11, write a rule for the sequence, then find the sum. So writing a rule means explicit or recursive. Um, and I almost always go with explicit. It's just a little bit easier to use. So explicit for the arithmetic is like a linear function. And then for the geometric, it has an exponent. That's supposed to be a times. And that is supposed to be an N, not an H. Let's see if I can fix that. N minus 1. Okay, so we have to look at this and decide, is it arithmetic or geometric? So arithmetic is when we add. Geometric is when we multiply. So here we've got 3, 6, 9. Those are all going up by adding 3. So we want to use the arithmetic. So the rule for the sequence, I'm going to say AN equals A1 is the first term, so 3, plus the difference, which in this case is also 3, and then the N minus 1 does not change. So this is the first term. This is the difference. And then on the geometric, just for your reference, A1 is still the first term and R means rate. Now they want us to find the sum. So this is where you'll look at your formula sheet. We've got the sum formulas. We do have an arithmetic, so we're going to use the arithmetic sum formula. So the sum of the first however many terms, well, we need to figure out how many terms are we adding up. So we're adding up from 3 to 45. So I'm just going to list them out after that 15 and count up the terms. So 15, 18, 42, 45. All right, so 1, 2, 3, 4, 5. So this is 6. I'm just counting up how many terms there are. That's a 10. So there are 15 terms, so I'm going to do the sum of the first 15. So we've got N is 15 times the first term, 3, plus the last term, 45, all over 2. So 15 times 3 plus 45 divided by 2. And I get 360. All right. Ms. V puts money in a magic jar. On day 1, she pulls the money out and finds she has $60. Each day, the money increases by 12%. How much money does she have in the jar on the 11th day? So increases by 12%. The rate is not 12. The rate is 1 plus or minus the percent of either increase, and that would be a plus, or decrease. So the rate is not 12. The rate is also not 13. The rate is 1 plus 0.12, or 1.12. Then we are going to use our geometric rule where AN, the 11th term, would be the first term times the rate and n minus 1. So A11, I would plug in the first term, $60, times the rate, and then up here, 11 minus 1. And then all this will go in my calculator. I would probably put it in my calculator with parentheses like this. So 60 times 1.12 raised to the 10th power. And so A11 is 186.35. I'm going to go to 2 decimal places because we're talking about money. All right. Question 13. Find the sums. So this is sigma notation, and looking at the 2 problems here, they both have an exponent, so they're both geometric. So that's kind of an easy check. Exponent equals geometric. So the sum is and actually let me write the formula first without any numbers. So the first term times 1 minus the rate to the nth power over 1 minus the rate. So n is 8. A1 is 3. The rate is 2. So 3 times 1 minus 2 to the 8th power over 1 minus 2. So pop that in your calculator. And I got 765. The next one is a tiny bit different because it has the infinity sign. This is called an infinite geometric. And the formula is just a little bit different. It's actually a little bit easier. We just take the first term divided by 1 minus the rate. So the first term is 4. That was supposed to be an S. The rate is 5, or sorry, not 5, 1/5. So 4 divided by 1 minus 1/5. And we get 5. All right. Next question. A fish population in a lake can be modeled by the recursive formula given below. So remember, a recursive formula has 2 parts, always. So I would say this is a little bit upside down from how we normally write it. I normally put the A1 first, but that is not a big deal. And then the AN, you multiply the rate and add the difference. This little part right here does not change. Don't plug anything in. Don't change the N. This is exactly how it is supposed to be. So don't change, don't plug in numbers. And then the question, so assuming the pattern continues, what will happen to the fish population over a long period of time? So this is one I usually did in the calculator. I would type in, so in your calculator, I would type in 130 and then hit enter. And then I would hit times 0.8. So on your calculator it would look like answer and then times 0.8 plus the 40 all in one line, and then hit enter again. And then keep hitting enter until your number stops to change, or stops changing. So I'm going to do 130, enter, times 0.8 plus 40. So then I hit enter, and I'm just going to write out some of the numbers I get so we can kind of see the pattern. You don't necessarily have to write these all down. So 130, 144, 155, at 0.2, I'm just going to round, 164. So I'm just going to keep hitting enter, and it's slowly going up. And then here in the 198s, it slowed down a lot. 199s, I'm getting a bunch of those in a row. So I'm going to say the population levels off at 200, because I'm sitting here looking at 199 and it's not changing very much. All right, next problem. Find the height of the person. So this is a right triangle. So this is a SOHCAHTOA example. So we're doing some trig. We have one angle, we have one side, we want the height. This is our x. So I'm going to label the sides. The hypotenuse is this long one, the base is the adjacent, and the one we want is the opposite. Well, I don't need the hypotenuse at all. It doesn't have any numbers on it. I'm not trying to find it. It's not helpful to me. So now I have opposite and adjacent. So looking at the SOHCAHTOA, we see O and A together with tan. So we are going to do tan of the angle 16 equals the opposite over the adjacent. I'm going to put tan over 1. I'm going to cross multiply. X equals 21 times tan 16. So just multiply those together. And I got 6.02. So I'm just going to round that to 6.0. The next one, I believe, is going to be quite similar. Find the measure of theta. That is asking you to find the angle. So once again, I'm going to label the sides. The longest one is the hypotenuse. The one across the triangle is the opposite. The bottom is the adjacent, but I'm not going to need it, so I'm not going to bother labeling it. I'm going to write out my SOHCAHTOA again. And then I have the H and the O. I have H and O in sine. So I'm going to do sine of the angle theta equals opposite over hypotenuse. Well, I want to get that sine by itself, so I need to get the theta by itself, so I want to get rid of the sine. So I'm going to do sine inverse, that sine with a -1. I'm going to do the same thing on the other side, sine inverse. So these go away. I'm left with theta equals the inverse sine of 9 over 17. And that's what goes in my calculator. 9 divided by 17. I got theta equals 31.96. I'm going to round that to 32. Okay, last page, which is our newest stuff, so hopefully should be the easiest. Question 17, solve for both x and y. So this is just more SOHCAHTOA. I'm going to write out my SOHCAHTOA. It's a funky looking A. There we go. All right, so our angle is the 32. The side we know is the hypotenuse. The x is the adjacent, and the y is the opposite. So I'm going to find x first. So for x, we have adjacent, and I know hypotenuse, so I'm going to do cosine. Cosine of 32 equals adjacent over hypotenuse. I know a lot of you are going to be tempted to round the square roots and put a decimal instead. Your calculator's doing all the work anyways, so just leave it how it is. Round your answer at the very end. So cross multiply, x equals the square root of 170 times cosine 32. That goes in my calculator. So square root 170 times cosine 32. And I got 11.1. I'm going to do some rounding. Okay, and then y. So here we've got, I'm going to erase some of my markings here for the next one. Oh, it's not letting me erase. Okay. So for y, that's my opposite, and I still have the hypotenuse. So opposite and hypotenuse, I'm going to use sine. So sine of 32 equals y over the square root of 170. Oh, that's a bad looking 7. And then put this over 1. Our work is going to look very similar, but now it's just sine instead of cosine. Sine 32. And here I got 6.9. All right, next question. Solve cosine theta equals negative square root 3 over 2, given that theta is in quadrant 3. So I'm just going to draw a quick little reminder. 1, 2, 3, 4. We've got 0 and 360, 90, 180, 270. Okay. So the first part is easy. The first part you just pop in your calculator. The inverse cosine of the number they gave us. So inverse cosine, negative square root 3, and then make sure you get out of the square root before you hit divide by 2. So I got 150. So 150 is not in quadrant 3. 150 is in quadrant 2. So here is my 150. This little reference angle is 30. So I'm going to use that reference angle to find the correct answer. So in quadrant 3, I'm going to draw the same reference angle. And now my answer is more than 180. It's in quadrant 3, which is more than 180. So 180 plus 30, and I think that's 210. Let me double check. Yeah, 210 is our final answer here. So question 19, into our law of sines and law of cosines stuff here. We want to find the length of segment AC. So they labeled the capital letters. I'm going to put in some lowercase letters. So little a, and then this would be little c, and this would be little b. So segment AC is the same as saying little b. So looking at this picture, are we going to do law of sines or law of cosines? So law of sines is when we have a match. So do I have an angle and a side that match up? Law of cosines is when I have no match. I don't have both an angle and a side of the same letter. Here, I've got A and A. So that tells me I'm going to do law of sines. There we go. So let's set up our fractions. We have sine 131 over 34. And then the only other number we have is that 21. So this is going to be a couple step problem because we are going to have to find angle C before we find that lowercase b. So we've got sine capital C over lowercase c, 21. And we've got to do some cross multiplying here. So I'm going to skip a step a little bit because I'm a tiny bit worried about space. So cross multiply, we would have the 21 times the sine 131, and then the 34 would be on the bottom. So when we put that in the calculator, we should get a decimal. And I got sine C equals 0.466. Remember, when we have sine of something equals a number, we want to make sure and do at least 3 decimal places. All right, so we're going to do our inverse sine to get rid of the sine. So these cancel, and we get C equals inverse sine 27.8. All right, now we have to do it all again. So now we need to set up our fractions and solve for lowercase b. So like I said, I did not give myself a lot of room here, but we'll make it work. Before I can set up my fractions, I need to find angle B. So to find angle B, I'm going to do 180 minus 131 minus 27.8. So angle B equals 21.2. So that's what I'm going to use for my next law of sines fractions. So sine 131 over 34. That is exactly the same as this fraction here that we started with. Now my new angle, sine 21.2 over lowercase b. Let's cross multiply these. And we get b equals, I'm going to cross multiply and divide at the same time here. 34 times sine 21.2 over sine 131. So b equals 16.3. All right. Oop. I thought that was a highlighter. Now the next part of the question, find the area of the triangle above. So I've got all the angles, I've got 2 sides. I've got all the angles, I've got all the sides. So we can pick whatever formula we want. I think the one that uses two sides and an angle is a little bit easier. Partly it's only one step. The one that uses all three sides, you have to find that S thing first. So 1/2. It doesn't really matter which sides and which angles I do. I'm going to do sides B and C and angle A. So I'm going to do 21. I'm going to do the 16.3 that we found, and I'm going to do the angle in between them. So sine 131. There are other correct ways to do this. This is just one possible way. Sine 131. And I got 129.2. All right. Now, number 20. And all right, I'm just going to go all the way over so I have all this space to work with. So number 20, find the segment, the length of segment AC. So that is once again B. This down here is C, and this over here is A. So if deciding between sines and cosines, well, do we have a match of an angle and a letter? And cosines is when we have no match. So looking at it, I don't have B and B. I don't have A and A. And I don't have C and C. I don't have any pairs where I know both the angle and the side. So I cannot do sines. I have to do cosines. So cosines, we are trying to find the side. So there are the two formulas for cosines. Make sure you use the one that's for a side. And it starts with a letter squared. So we're trying to find B, so I'm doing B squared. Then we have the other two sides squared. It doesn't really matter which one comes first. Minus 2 times those same two sides times cosine of the angle in between them. And all that pops in your calculator. So 11 squared plus 15 squared minus 2 times 11 times 15 times cosine 116. And B squared equals 490.7. So now I square root. B equals 22.2. You might get 22.1 depending how you rounded. If it's close, it will be marked correct. Don't worry too much about that. All right, now find the area of the triangle above. If I was doing this on my own, I would 100% do the same formula I just did before, the 1/2 A times B times sine C. Because this is to help you for the test, I do want to show you the other formula, just as a reminder. So although I honestly would not do this if I was taking the test myself, I just want you to see all the possibilities. So I'm going to use the area formula where we got to find S. So we add up the three sides. 11 plus 15 plus 22.2, and we divide that by 2. I got 24.1. Then the area equals a big old long square root here, and we take that 24.1 and we subtract each side from it. Remember, your S, what you just found up above, has to be longer than all your sides. If S is shorter than a side, you did something wrong. Probably forgot to use parentheses in your calculator. All right, so 24.1. I'm just getting this all typed in. So minus 11, and then minus 15, and then minus 22.2. And that was all under a square root. So the area is 73.88. I'm going to round that up to a 9. And there we go. Very last question on the test here. Solve the triangle. That means find all parts. Okay. In this case, that would be all the angles. So remember, we need to start with the biggest angle. I'm going to label these just so for simplicity. So I'm going to call that A, and down here B, and over here C. And then the opposites are the lowercase letters. So we need to do A first. Because we have all three sides, we don't have any angles. I cannot do law of sines. Remember, law of sines, I for sure have to have one side and one angle that match up. And I don't have that. So I'm going to do cosine of angle A equals the other two sides first. 16 squared plus 17 squared minus the side that matches up with the angle. So this angle and this side should be from the same letter, and they should be across from each other in the triangle. And then on the bottom, we've got 2 times 16 times 17. Parentheses are on the top, parentheses are on the bottom. Let's get that in your calculator. It will be a decimal. It might be negative. All right, 16 squared plus 17 squared minus 23 squared divided by 2 times 16 times 17. And I got 0.029. So remember, if you get a trig function equals a number, we got to go at least 3 decimals, and I'm even going 4 right now, just for fun. So to get rid of this cosine, we need to do the inverse cosine. So these cancel. A equals 88.3. All right, 1 down, 2 to go. So you could do all this again. I'm actually going to switch to law of sines. I feel like it goes a little bit faster. So now we can pick B or C. I'm just going to go with B next. So I've got sine of 88.3 over side A, 23, equals sine of B over 17. Cross multiply that up. Sine of B is 17 times sine of 88.3 divided by 23. Let's pop that in the calculator. And I got sine B equals 0.7388. Do some good old inverse sine. And I got B equals 47.6. B is 47.6. For the last one, I'm not even going to use any trig. I'm just going to use 180 minus the two angles we already found. I got 44.1. And there we go. The triangle has been solved. All its parts are labeled and identified. All right, let me know if you have any other questions. This page got a lot longer than I thought it was going to. And good luck.